Today I'm going to give you 3 trig properties you need to know to solve trig limits, and I'm going to give you a trig toolbox of 6 strategies that will help you solve trig limit problems. The first thing you're going to need are these 3 trig limit properties, so please write them down. And I highly suggest that you have another sheet of paper, maybe even a colored sheet of paper, where you keep all of your trig helpful hints. Anything that you need that you're going to be using for all of these trig problems, I highly recommend you put on a separate sheet of paper that you can easily pull out. It would be known as like your trig limit cheat sheet, right? To give you some ideas to get going. So write down these 3 trig limit properties. Next, we're going to talk about your trig toolbox. Here I have 6 strategies for you to use when solving trig limit problems. The first one is just going to be to plug it in. That's always going to be the easiest. It's always the one you try. Unfortunately, it's probably the one that is not going to be used most often. The second toolbox trick is to look for the limit when x goes to 0 or infinity, when you have sine x over x or x over sine x. The third trig limit toolbox is the magic 1, and we're going to use this in 2 different ways. First is a combination of constants. What are constants? Constants are just numbers. The other way we're going to use this is when we're talking about a conjugate. Again, when we're talking about switching the plus or the minus sign in the middle of 2 terms. So I've got an example for you. If we've got 3x plus 1, then a magic 1 we might use would be 3x minus 1. Trig toolbox number 4 is you're going to rewrite everything in terms of sine and cosine. So anytime you get tangent, cotangent, secant, cosecant, you want to rewrite those ratios in terms of sine and cosine. Toolbox tip number 5, you're going to try to pull things apart. So an example in this one, when you have sine squared x, you're going to pull that apart into 2 different pieces. So then you can use one of those properties we talked about in the beginning. In toolbox option number 6, get rid of your fractions by multiplying by the common denominator. Now it's time to do some example problems with using our trig properties and our trig limit toolbox. The first problem we have is the limit as x goes to 0 of sine of 3x over x. First thing we want to try to do is plug in, right? We plug in, we're going to have 0 on the bottom, so that's not going to work. But hopefully what you're starting to recognize is one of those trig properties that I gave you. So in your mind, you want to start thinking about which trig limit property do I want to use. And in this case, because we have sine x in the numerator, we want to use this property where this is going to equal 1. So this is the property that we're looking to use. But currently in this problem, sine of 3x, we need a 3 in the denominator. So what we can do is use a magic 1 of 3 over 3. This will now give us the limit as x goes to 0 of sine 3x over 3x, and in your numerator you got a 3 hanging out there. So what's great is you'll see that this piece all goes to 1 using our property over here, and we're left with 3 times 1, which is 3. Let's try another problem. Again, you always want to try to plug in first. So let's plug in infinity. So we'll have cosine of 1 over infinity. Well, hopefully you remember that any number over infinity, that thing is headed straight to 0. And if you don't remember that, go ahead and put 1 divided by, put a whole row of 9s in your calculator, right? So we're headed towards infinity. A bunch of 9s, and you're going to get an answer that'll give you e to the negative whatever digits you got. And as you can see then, you're going to be putting a 0 in front of that, or a decimal, and followed by a bunch of zeros, which means that thing is heading to 0. So this guy is heading to 0. So now you have the cosine of 0. And hopefully you all remember your trig to know the cosine of 0 is 1. So that's a pretty straightforward, easy plug-in problem. Okay, for this problem, x is heading to 0, so we can't plug in because that gives us 0 in the denominator. That's no good. So the next thing is we see tangent, and one of our trig tools was to rewrite tangent in terms of sine and cosine. So that's the very first step we're going to do. So the limit as x goes to 0, and tangent becomes sine x over cosine x all over x. Now we have a fraction inside of a fraction, which is no good. So we're going to rewrite this, and the way you do that is you take your denominator and you flip it and you multiply. So let me show you. This guy here is really x over 1. So what we have is the limit as x goes to 0, sine x over cosine x times 1 over x. This piece became that. Now hopefully you start recognizing this limit, this piece right here. This thing equals 1. So now we have left 1 times 1 over cosine at 0. Because that's this piece that we had left. We plugged in our 0. And cosine of 0, we know that this guy is 1. So 1 times 1, 1. All that work for 1. Okay, again, looking at this problem, you plug in x in the denominator, you're going to get 0. So we cannot plug in. Some other strategies that we can use is, hopefully you see the sine x in the numerator, which should make you think of one of the trig properties. And we have an x in the denominator. We just need that x to have a 3. So we're going to start with multiplying by a magic 1 using 3's. When we do this, we've got the limit as x goes to 0. And in the numerator, you've got 3. Then you've got sine 3x all over. And in the denominator, I'm just going to write this guy with the x. And we can do that because multiplication rules state that you can rearrange if they're all connected by multiplication. So now hopefully you see our limit property, which is this piece right here, and this whole thing equals 1. So now we have 3 in the numerator times our limit property, which equaled 1, over cosine of 2 times 0. So again, we know this guy, cosine at 0, right? The 2 is going to multiply out. Cosine of 0 is 1. So we have an answer of 3. In this problem, again, you cannot plug in infinity, but this is one of those where we can use the trig toolbox of pulling things apart. So I'm going to rewrite this problem as the limit as x goes to infinity. And we have sine x over x times x. And hopefully you're getting excited because you see the limit property right here. Now remember, this limit property equals 0. And then we have to multiply by 1 over infinity because we're plugging in our x value. Well, 1 over infinity, where's that guy going? He's going to 0 too. So you've got 0 times 0, which gives you 0. Now this problem's a little trickier. We can't plug in for this one. We can't rewrite in terms of sine and cosine, but we can use a magic 1 and multiply by the conjugate or multiply to get rid of the fraction in the denominator. And so that's what we're going to work on right here. We're going to multiply this problem by 1 over x. So now we have the limit as x goes to infinity of sine, and now I'm going to do my numerator. This times 1 over x times pi x is just going to be pi. And in the denominator, we're going to have 2 over x minus 3 because my x's will drop out. Now we can go ahead and plug in infinity. Now we have sine of pi over 2 to infinity minus 3. Well, this guy goes to 0. So now we're left with sine of negative pi over 3. Hopefully you all remember your trig. So where is negative pi over 3? If we draw a triangle, negative pi over 3 is down over here. Pi over 3 is a 60-degree angle, so that's what goes in the corner. So your 30 degrees is down here and your 90 is here. Your 30, 60, 90 ratio, 30, 60, 90. And this guy's a negative y value, right? Because it's dropping down. So sine is opposite over hypotenuse. So if you're standing here in the corner, the opposite guy from you is negative square root of 3, and your hypotenuse is 2. Let's try this one. This one's going to be fun. So the first thing that we see here is we have a sine x in the denominator, which means we can use one of our sine properties. And we also have tangent, which we need to rewrite in terms of sine and cosine. So I'm going to start with that. The limit as x goes to 0, sine 7x over cosine 7x all over sine of 3x, which never looks good when you have a fraction inside a fraction. So I'm going to take that bottom fraction and flip and multiply. So the limit as x goes to 0, sine 7x all over cosine 7x times, we're going to take this denominator, this is how this guy would be written as a fraction. We're going to flip him and multiply. So that becomes 1 over sine 3x. This is our problem so far. Now we have a sine x in the numerator and 1 in the denominator. For this to work with our property, we also need that same constant and variable in the opposite position. So watch what we're going to do. This sine 7x needs a 7x in the denominator. So what I'm going to do is make a magic 1 of 7x, which means it also needs to be in the numerator, because then I'm just multiplying by 1 and not changing the problem. Now we have this sine 3x, which also needs a 3x in the numerator. So I'm going to multiply by another 3x in the numerator denominator, just another 1, not changing the problems, but now we can set up our properties. We have the limit as x goes to 0. I'm going to rearrange the order that I write these so you can see where they're coming from. And then in the numerator, I'm left with 7x. And in the denominator, I'm left with cosine 7x and a 3x. Here's our 7x property, that this guy is going to be a 1. Here's our 3x property, where this guy is going to be a 1. And we also have something else. Our x's here are going to go ahead and cancel each other out. So those x's will also drop. Now we can go ahead and rewrite what we have left with plugging in our x value. So what we have left is 7 in the numerator over 3 cosine of 7 times 0. Well, we know that this piece is cosine of 0. This is going to be 1. So 3 times 1 is what we have left in the denominator. So we have a total of 7/3 for our answer. So this problem is an example where we're going to change secant in terms of sine and cosine. And hopefully you remember that secant is 1 over cosine. So I'm going to start with rewriting this problem. We have the limit as x goes to 0. secant turns into 1 over cosine of x minus 1 all over x times 1 over cosine of x. Now this doesn't look very good because we've got fractions inside of fractions. So another toolbox trig option we have is to multiply by the common denominator. And in this case, it's cosine x. So that's going to be my next step for my magic 1, is to be multiplying both the numerator and the denominator by cosine of x. So I'm going to multiply by cosine of x over cosine of x. Now let's multiply through. Cosine of x times 1 over cosine of x equals the limit. As x goes to 0, your cosines are going to cancel. You're just going to be left with 1. Now, cosine of x times minus 1 minus cosine of x. Now we're going to do that in the denominator. Your x is going to stay, and your cosines are going to cancel themselves out. But now we have another problem. If we plug in 0 to this problem, you're going to get a 0 in the denominator, which is no good. So we need to multiply now by a conjugate to get rid of that x in the denominator so it doesn't go to 0. Watch this next step. We're going to multiply by 1 plus cosine x. You have to do that in the numerator and the denominator because this is our magic 1. Put the numerator in parentheses, and now we need to multiply this problem out. So we have the limit as x goes to 0. And what happens when you multiply factors that are conjugates of each other? Their middle terms drop out. So 1 times 1 is 1. But 1 times negative cosine x, and then we go through and do it the other way, where you take cosine x times 1, that's going to be the positive. Those are going to drop, so I'm not even going to write them. But then you have cosine x times cosine x. We have minus cosine squared x. And then in the denominator, I'm just going to leave this with x times 1 plus cosine x. Now hopefully you have little bells ringing in your head. Anytime that you have a cosine squared and a 1, you should be getting super excited about your trigonometry right now. Let me tell you the property in case you forgot. So what you should be thinking is, I remember a property that says sine squared x plus cosine squared x equals 1. And if I subtract this cosine x to the other side, you have sine squared x equals 1 minus cosine squared x. And you should be getting super happy, because now what we can do is we can take out our 1 minus cosine squared x and put in sine squared x. So now we're going to substitute in the limit as x goes to 0. Our numerator is sine squared x, right? That's from this little doozy over there. All over x times 1 plus cosine x. Now what we can do is pull apart that numerator into 2 sine x's. So then we have a property with that x in the denominator. So now we have the limit as x goes to 0 of sine x times sine x all over x times 1 plus cosine of x. And then hopefully you're seeing this property right here. And that guy we all know is going to be 1. So now what we can do is go ahead and plug in our x value of 0. We have sine of 0 all over 1 plus cosine of 0. Well, cosine of 0 is 1, and sine of 0 is 0. So you have 0 over 2 in the denominator, which gives you a total of 0. All that work for 0. All of that. Wasn't that a fun one?